Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, welcome to lecture 33, Organic Chemistry 2. Today we will start on chapter 8, Carboxylic acid derivatives. Nomenclature of acid derivatives. What do you mean by carboxylic acid derivatives? They are compounds with functional groups that can be converted to carboxylic acids by simple acidic or basic hydrolysis, like acid halide, anhydride, ester, amide, and nitrile. Let's start with ester. Carboxylic acid, when reacted with alcohol in catalytic amount of acid, it gives ester. We call this Fischer method. The name of esters consists of two words that reflect their composite structure. The first word is derived from the alkyl group of the alcohol, and the second word from the carboxylate group of the carboxylic acid. By remove the IC from the name of the acid and replace it by ATE. What is the name of this compound? With IUPAC, it is 1-methyl ethyl space methanoate. Remember that this part comes from the alcohol. And according to IUPAC, to name this as a group, this will be number 1 and this is number 2. On number 1 we have methyl, so this group is called 1-methyl ethyl. And this acid is methanoic acid. Takes the IC out, so it will be methanoate. Takes the IC out and put the ATE, so it will be 1-methyl ethyl methanoate. What about the common name? Remember that this group, common name called isopropyl, and that acid is formic acid, so it will be isopropyl. Take the IC out, add ATE, so it will be isopropyl formate. Isopropyl formate. Give the common and IUPAC name for each compound. This compound, as you can see, this is methyl, and here is benzoic acid. Take the IC out, so it will be methyl benzoate. Here we have ethyl, so it will be ethyl. What about this one? This is cyclohexane carboxylic acid, so it will be cyclohexane carboxylate. All right? Cyclic esters are called lactones. A lactone is formed from an open chain hydroxy acid in which the hydroxyl group has reacted with the acid group to form an ester. The IUPAC name of the lactone are derived by adding the term lactone at the end of the name of the parent acid. The common name for the lactone used more often than IUPAC names are formed by changing the IC of the acid ending of the hydroxyl acid to O-lactone. Let's see. We have here the acid OH, and here is C double bond OH, carboxyl group, Elimination of water will form the cyclic ester we call lactone. Now, for what is the name of this compound? IUPAC. This is 4, 1, 2, 3, 4, 4 hydroxybutanoic acid. So we will add to that lactone. So the cyclic structure here will be 4-hydroxybutanoic acid lactone. What is the common name of this acid? This is gamma, alpha, beta, gamma. This is gamma hydroxybutyric acid. What we are going to do, take the IC out, so it will be gamma butyrolactone. Add O-lactone. Gamma butyrolactone. Lactones formed from aliphatic acids are named by adding Halides to the name of the non-hydroxylated hydrocarbon with the same number of carbon atoms with elision of terminal E. Here we have cyclic ester, lactone structure with 1, 2, 3, 4 carbon with 4 carbons. The connection here we have the O on carbon 4, so it will be 4 butane. Take the E out, olide, so it's for 4 butanolide. Here we have 1, 2, 3, 4, 5 carbons. The connection from position 3, so it will be 3 pentanolide. If we have the connection on 5, that will be 5 pentanolide or 5-hydroxybutanoic acid lactone. Common name, the name of C5 valeric acid. It's connected from delta position, so it will be delta valerolactone. Amides are formed by reacting carboxylic acid with amine and heat. Unlike amines, amide are only weakly basic, and we consider amide function group to be neutral. We need concentrated strong acid to protonate amide, and the protonation occurs on the carbonyl oxygen. The protonation occurs on the carbonyl oxygen rather than nitrogen. Why? Because of the electron withdrawing negative mesomeric effect of the carbonyl transfer this lone pair from nitrogen to oxygen. So the protonation occurs on this oxygen, and again this structure is in resonance with the structure where the positive charge on nitrogen. We can classify amine as a primary, secondary, tertiary amide. When the amine is in H2 here, that's the primary. In HR prime, we call secondary. R prime, R double prime is tertiary. To name it, get the corresponding acid IC or OIC out suffix and add a suffix amide. For secondary and tertiary amide, treat the alkyl groups on nitrogen as substituents and specify their position by the prefix N. What do you mean? Okay, let's see. We have here 2 carbon, so this is ethanoic acid. So it will be ethan, take the OIC out, and add amide. So it will be ethanamide. These two, by common name, this is acetic acid, 2 carbon. Okay, so it will be, take the IC out and put amide, it will be acetamide. It will be acetamide. Okay. For this one, we have here methyl, and we have only 1 carbon for the acid, so that's methanoic. It will be methanamide. And we have methyl on nitrogen, so it will be N-methyl methanamide or N-methyl formamide. Here we have 2 methyl on nitrogen, so it will be NN dimethyl methanamide or NN dimethyl formamide. Name the following compound. This compound main structure is carbon 2, 3, 4 carbon, and functionality is amide, so it's propanamide. We have ethyl group on nitrogen, and we have methyl groups on nitrogen and on carbon 2. Alphabet, ethyl comes first, so it will be N-ethyl, then N2 dimethyl propanamide. Common name, N-ethyl N-methyl isobutyramide. Since you have here carbon 2, 3, 4 iso, that's isobutyric acid. Now we have taken this out and added the nitrogen. With substituent, it will be butyramide. For acids that are named as alkane carboxylic acid, will replace the carboxylic acid by carboxamide. So it will be here cyclopentane carboxamide. Here we can say it's N-phenyl ethanamide, N-phenyl methanamide, N-phenyl ethanamide with 2 carbon, or N-phenyl acetamide, common name, and another popular common name, acetanilide, and it's used frequently as acetanilide. Cyclic amides are called lactams. Lactams are named by adding the term lactam at the end of the IUPAC name of the parent acid. Common names of lactams are formed by changing the IC in the acid name ending of the amino acid to O-lactam. Let's see, here we have this lactam, cyclic amide. It came from carboxylic acid and amino group. You break in here. The name of this acid is 4-amino-butanoic acid. So the IUPAC name will be 4-hydroxybutanoic acid lactam. What about the common name? The common name here is gamma-amino-butyric acid. Now, naming only the acid, okay, 1, 2, 3, 4, so a butyric acid. So this one will be gamma-butyrolactam. You don't mention the amino because the part of the name, lactam, which will contain the cyclic amide. Here, this cyclic amide again comes from carboxylic acid, 2, 3 carbons, and NH2. That's 1, 2, 3. So the name of this acid is 3-amino propanoic acid. IUPAC name for the cyclic lactam will be 3-amino-propanoic acid lactam. Common name for this acid, beta-aminopropionic acid. So we'll take only the name of the acid. So we beta-propionolactam. Beta-propiolactam. Here, this cyclic amide comes from the carboxylic acid, aminocarboxylic acid, 4-amino, 2-methyl bentanoic acid. So the IUPAC name of the lactam will be 4-amino 2-methyl bentanoic acid lactam. This acid with 5 carbon, common name called valeric acid. Valeric acid, so the common name for the lactam will be alpha methyl gamma valerolactam. For this one, the acid and the amino, alpha, beta, gamma, delta, epsilon. So it will be 1, 2, 3, 4, 5, 6, 6-amino hexanoic acid lactam. For the common will be epsilon. Caprolactam. Caprolactam. Epsilon caprolactam. Nitriles. Although nitriles lack the carbonyl group of carboxylic acid, they are classified as acid derivatives because they hydrolyze to give carboxylic acid and can be sensitized by dehydration of amide. So nitrile, when treated with water in acidic media or basic media, provides amide. Amide, under the action of phosphoryl chloride, or we call it phosphorus oxychloride, dehydration takes place and go back to nitrile. Amide can be hydrolyzed in acidic media to give the carboxylic acid. Also, the carboxylic acid reacts with ammonia and heat to form the amide. Although nitrile has a lone pair of electrons on nitrogen, it is not very basic. A typical nitrile has pKb of about 24, requiring a concentrated solution of mineral acid to protonate the nitrile. We can explain that due to the lack of this basicity by noting that the nitrile lone pair residue on sp hybridized orbital with 50% s character. This orbital is close to the nucleus, and these electrons are tightly bound and relatively unreactive. So if we have a compound has two function groups, ester and nitrile, we can, under mild condition using DOX acidic 50, in water and heat, we can hydrolyze actually the ester to carboxylic acid and retain the cyano group or nitrile group untouched. You can see one of the publications commenting about that, Synthetic Communication, 1986, volume 19, page 627. The IUPAC name is constructed from the alkane name with the suffix nitrile added. For the common names of nitriles, they are derived from the corresponding carboxylic acids. Begin with the acid name, replace the IC of the acid with the suffix O-nitrile. Here we have one carbon, two carbons. So that's ethane nitrile. That's IUPAC. It is a common name. Two carbon means acetic acid. So it will be, take the IC out, it will be acetonitrile. Take the IC and add O-nitrile. So acetonitrile. Here we have 1, 2, 3. It will be IUPAC, propan, then nitrile. For the common will be propionitrile. We have here 1, 2, 3, 4 carbons, right? That will be 3-hydroxy butanitrile. For the common name, here is alpha, here is beta, that's beta-hydroxy butyrolnitrile. For acids that are named as alkane carboxylic acid, we replace carboxylic acid with carbonitrile. Here is example: cyclopentane carbonitrile. Cyclopentane carbonitrile. For the cyanide, SN group can be named as a substituent cyano group. Here we have 1, 2, 3, 4 carbon with senior, we'll get to that later, senior group carboxylic acid. So the compound will name as a carboxylic acid. 1, 2, 3, 4, 5. It's bentanoic acid. This is carbon number 1 and this is carbon 2. On number 2 we have cyano group. So the compound is 2-cyanobentanoic acid. 2-cyanobentanoic acid. Acid nitrile R C double bond OCl is named by replacing the IC suffix in either common name or IUPAC with YL and then halide. Write the halide name. Here we have 1, 2. It is ethanoic acid. Take the IC out and put YL. So it will be ethanoyl chloride. Ethanoyl chloride. Ethanoyl chloride. What about the common name? It's acetic acid, 2 carbons, right? So it will be, take the IC out and put the IYL. So acetyl chloride. It will be acetyl chloride. Here 1, 2, 3, 4. It's butanoic acid, so it will be butanyl bromide. Butanyl bromide. 1 and 2. On number 2 we have bromo, so it's 2-bromo butanyl bromide. Or common name alpha beta. So alpha bromo, so it will be alpha bromo butyryl bromide. For this one here we have cyclopentane carboxylic acid. It will be carbopentane carbonyl fluoride. Cyclopentane carbonyl chloride. So if you have compound, the acid called alkane carboxylic acid, it will be alkane carbonyl halide. Cyclopentane carbonyl fluoride, because we have fluoride in here. Here is bromide, here is chloride. Acid anhydride. Acid anhydride nomenclature is very simple. Just write the name of the acid and end by anhydride after a space. Here we have ethanoic anhydride, 2 molecules of ethanoic acids. Eliminate water, it will be ethanoic anhydride. Common name, the acid with 2 carbon, acetic. It will be acetic anhydride. Here we have benzene 1,2 dicarboxylic anhydride. what we call it, because the common name of the acid phthalic, it will be phthalic anhydride. Anhydrides composed of two different acids are called mixed anhydrides and are named by using the names of the individual acid. Here we have the structure of anhydride. It came from ethanoic and methanoic acid. Eliminate water, it provides ethanoic, methanoic anhydride. Since we can name the acid by name, common name, here is acetic, here is formic, so it will be also common name acetic formic anhydride. To summarize the functional group nomenclature, the priority for naming the parent compound will be acid, then comes ester, amide, nitrile, aldehyde, ketones, alcohol, amine, alkene, and alkyne. So acid will give the highest priority, then the ester, then the amide, etc. If we have carboxylic acid, we name the alkane, take the E out, and then add OIC, so oic acid. If it's substituent, we say carboxy. For ester, as we mentioned, we take the IC of the name and O8. Or we say alkoxycarbonyl as a substituent. Amides, amide name, suffix. Amido as a group. Nitrile as a main group. Cyano as a substituent. Al as an aldehyde. Formyl as a substituent. Ketone, on as a main group. Oxo as a substituent. Alcohols, all as a main, hydroxy as a substituent. Amine as a main group and amino as a substituent. In as a main parent compound, alkenyl substituent. Yen as a main, alkynyl as a substituent. ANE as a main for alkane, alkyl as a substituent. Ethers, alkoxy. Halides, halo as a substituent. Give appropriate names for the following compounds. What is the name of this compound? It has C double bond O, ketonic function group. Well, this is a long chain containing the carbonyl. 1, 2 shortest to the carbonyl function group. 3, 4, 5, 6. So that will be hexanone, hex 2 on, hexane 2 on. And on carbon 4 we have methyl, so it's 4-methyl hexane 2 on. Here we have anhydride of two different acids. This is one, and this is the second one. This is benzoic, and this is formic, or benzoic methanoic. It will be benzoic, formic, anhydride. Here we have amide functionality. And on N we have phenyl group. So it will be N-phenyl. It has here 2 carbons. So ethanamide. N-phenyl ethanamide. Or N-phenyl acetamide. N-phenyl acetamide. And we mention that the name of this compound acetanilide and still in use, common name or trade name. For this compound, here we have the acid, and we have O phenyl, that is an ester, so it is phenyl acid with 2 carbon ethanoic. It will be ethanoate because it's an ester, so it is phenyl ethanoate, or common name, that's 2 carbon, it's acetic acid, so it's phenyl acetate, right? Okay, here we have again amide, that's benzamide. On the nitrogen we have 2 ethyl groups. It's ethyl, and this is an ethyl. And here on carbon number 3, because this will be number 1, 2, 3, we have methyl, right? So we have here N diethyl 3-methyl benzamide, and N diethyl 3-methyl benzamide. Okay, let's see here. This we have cyclic amide, we call it lactam. So here acid, here NH2 will be 1, 2, 3. The name of the acid, 3-amino-bentanoic acid, and we ended up by lactam, 3-amino-bentanoic acid, and then since it's cyclic, lactam. Draw structures to correspond with the following common and systematic names. Cyclohexyl benzoate, it's an ester of benzoic acid. So we draw the benzoic acid, then take the H out and put the alkyl group in here, cyclohexyl, that's it. Benzoic propionic anhydride. Draw the benzoic, draw the propionic, eliminate water and form the anhydride. Gamma hydroxy valeronitril, that will be valeric acid, 5 carbon, that's 1, 2, 3, 4, 5. Alpha, beta, gamma, so alpha gamma hydroxy valeronitril. Ethyl, 3-cyano 5-methyl hexanoate. 8 means it's an ester, and the ethyl is the alkyl of that ester. It's hexanoate. So 1, 2, 3, 4, 5, 6. That's the acid. Ethyl, that's an ester. Here is 1, 2, 3, 4, 5, 6. 3-cyano, see in here, cyano. 5-methyl, hexanoate, that's it. N-ethyl, N4-dimethyl bentanimate. Bentanimate means that we have 1, 2, 3, 4, 5, That's pentanimate. Here is 1, 2, 3, 4. On nitrogen, say ethyl, N-ethyl. So we have ethyl. We have N and 4, we have methyl, N, methyl, and 4, methyl. That's a structure. E, 3 ethyl, 7 methyl, oct 4 in nitrile. We have octanitrile, 8 carbons with triple bond N. 1, 2, 3, 4, 5, 6, 7, 8. So that's the parent. Okay, that's the main. Now we have on carbon 4, we have double bond. 1, 2, 3, 4. That's it. We have double bond. This double bond, the group around it is E. Main here and the main here are at different positions, orientation. They are E. That's right. Okay. Now we are done with E. We are done with the main. Now 3 ethyl. 1, 2, 3. Ethyl. Okay. And 7 methyl. 3, 4, 5, 6, 7. 7 methyl. So this is a structure. Okay. See you in next lecture.